Okay, so we're going to go ahead and graph yx is equal to 2. Okay, so this is going to be an interesting problem, and this is going to be an introduction to maybe some of you out there who haven't tackled a problem like this to a little bit more advanced concepts. Okay, so this is not just a simple line or some basic shape. We're going to have to get into a couple of things here with this particular problem. So if you were like looking at this, you're like, y times x is equal to 2. I'm used to graphing things like, let's say y is equal to 2x plus 1, which is a nice line, or maybe something like y equals x squared, which is a quadratic equation, a nice parabola. But this is not a line or a parabola, it's something else, okay? And in order to graph this, we need to, one, identify what we're looking at, and two, know something about the subject, okay, a little bit deeper, right? Now, of course, I'm not telling you this right now because I want to just build up the suspense because math is so cool. It's like, think about it. What would you rather be doing, math or watching a nice suspenseful action movie? Of course, you want to be doing mathematics, right? Anyways, we're going to get to this problem here in just 1 second, and it's worth your while to stick around because I'm going to show you an approach for you to be able to graph anything. So if you weren't able to graph this or you were confused about it, I want to tell you one thing that you could always use in order to graph anything. So you want to stick around here, but before I get into this, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over many years I've constructed what I like to believe is one of the best online math help programs there is. I'll let you be the judge of that. If you're interested, you can find a link to my math help program in the description of this video. So I offer full courses, but if you're taking a course right now, let's say college algebra, algebra 2, whatever the case might be, you can certainly use my program to help you along if you need additional help beyond what you're getting in the classroom. Okay, I teach you how to solve the most common problems in middle and high school math and even basic college math. Literally, I solved thousands and thousands of problems. It's taken me years to build my program out, and it's helped a lot of people. Very proud of it. So if you are struggling in math, do something about it. Okay, take a look at your options, and I think my math help program would be an excellent option for you. But one thing that is not an option if you are a math student is taking great notes. Okay, my golden rule of math is those students who take the best notes almost always get the best grades, and the reverse is true. Those students who don't take good notes, maybe they don't take any notes, maybe sloppy notes, or maybe they only take notes on Monday. Okay, and they're like, that's good enough because my best friend is over there and he takes better notes than me. And I don't like my handwriting. His handwriting's better, so I'll just take his notes and copy his notes, etc., etc., etc. Because I got to do my homework for my other class right now. You kind of get the picture, right? I'm not trying to make you feel bad. Maybe in some way I am, but I am trying to inform you that if you're doing this, okay, if you're not taking each class session, okay, with your teacher critically important and focused in on what they're saying, you're going to miss stuff, right? And if you do this every day or every time class comes along, you're going to miss everything and it's going to show up in your grades, okay? So obviously, if you're watching this video, you're interested in learning math, and if you're interested in learning math, let's get you to have an outstanding math grade, all right? So it's definitely possible, but it's not possible without you taking great math notes. So um, start improving if you need to improve, but in the meantime, you need something to study from. So I offer detailed comprehensive math notes. Those would include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find a link to all those notes in the description of this video as well. Okay, so let's get into this. So we have yx is equal to 2. So what are we dealing with here? Well, here, if you look at these equations, this is a linear equation, and this is a quadratic equation. If you notice, we have y equals y equals. But here we have yx is equal to a number. So like, well, can we make this look a little different? And we absolutely can. We can just solve for y. Okay, so if we have y x is equal to 2. If I solve for y, okay, I want to solve for y only here, and you're like, well, how do I do that? Well, we have to think of x as a variable. I just did a video not too long ago on solving for the indicated variable in a problem, okay, and some students get confused on this, but basically the idea here is we're going to divide both sides of the equation by x, so y is equal to 2 over x. This is really what we're trying to graph. And of course, this thing right here is equivalent to this, but I want to see this equation in terms of y only. So we're really trying to graph y equals 2 over x. Okay, so what kind of graph is this? What kind of function are we talking about? So here we have yx is equal to 2, so we're really going to be looking to graph y equals 2 over x. Well, this is what we call a rational expression, okay? This is a rational expression, but actually it's a rational equation because it's an equation. So we're talking about graphing rational equations, okay? That's the topic here. And in algebra, there's a lot of different topics. There's radical equations, systems of equations, quadratic equations, linear equations. There's a lot of different topics, right? And of course, if you're taking excellent math notes, you would know each one of them in detail. But if you're not taking any notes at all, you'd be like, what? Rational what? Well, that's what this is. Now, this word rational in mathematics, okay, means fraction, right? You kind of think of it, there's some technical definitions here about it, but I just want you to remember fraction, all right? Just associate the word fraction to rational. But here, we have some sort of fraction situation. We have a variable down here in the denominator. So you got to know how to solve rational equations. But when you're solving any or graphing any type of particular type of function, you need to have the basic sense of basic feel for those type of functions. So for example, a linear equation, I'm going to get to all this here in a second. Here, let's go back up here real fast, okay? So like this guy right here, this is a linear equation. The root word there is line, so the graph of this guy is going to be some sort of straight line, okay? Quadratic equations, it's a parabola, so the graph of those type of problems is going to be some sort of U shape, okay? Parabola could be upside down, an upside down U, or an upside, or a happy U, like this. So you got to know the basic shapes that are associated with particular type of functions. So in rational equations, the basic shapes, there is not one particular type of basic shape, but we do get what we call branches. Branches, all right? So what is a branch? Well, a branch is typical things like this. You're going to get some separation, okay? These are like branches like this, okay? You're not going to have like one single line or like a polynomial equation nice and smooth and continuous. Oftentimes with rational equations, you'll get these kind of branch type of things like this, okay? So we kind of have to figure that out, and help us figure out where to graph these particular branches. We need to know where they're allowed to go on the XY plane. And that gets us into this concept of vertical asymptotes and horizontal asymptotes. Now I'm doing a quick, this is a very, very quick crash course on this. This is not a full lesson because this would be a pretty substantial lesson to learn how to graph rational equations. We're going to highlight, some of the basics there, but maybe I'll do an extensive lesson. Of course, you can take my Algebra 2 course or college algebra course. I get into this in detail. You'll be, you will have mastered this because I really, really get into this a lot. But, I'm going to just hit the highlights here, okay? So when we're dealing with rational equations, we need to, we already know that the basic shape is going to be, there's going to be some branches here, but what we have to do is determine what we call the vertical asymptote and horizontal asymptote, okay? And asymptotes are, let me just show you real quick if you're not familiar with that name, okay? An asymptote, let's say I have a line like this, okay? And this line is y equals 2. Now I made this a dotted line, but let's suppose I'm calling this an asymptote. An asymptote is a line, okay? We can have either a vertical line or a horizontal line, and there's no set rule whether you must have a vertical asymptote or you must have a horizontal asymptote. But if you do have them, what they are, they're lines, but they're boundaries, okay? They're boundary lines. And what basically the meaning of an asymptote or asymptotic behavior is that a graph will approach that asymptote, okay, but never touch it, but it will get infinitely closer to it. So for example, we can have some sort of graph like this, get closer and closer and closer to that asymptote, if this is my asymptote, but it's never going to cross over. It's just going to get infinitely closer to it, right? Maybe it can maybe approach it in this way as well, okay? So get very, very close to it. So these asymptotes are very important, okay, to determine what we call like these branches, okay? So right here, this y equals 2 is what? This is a horizontal line, so this would be an example of a horizontal asymptote. All right, a vertical asymptote, of course, would be a vertical boundary like this. Now, oftentimes, the x and y axis can actually serve as an asymptote as well. So we have to know the procedure to find vertical and horizontal asymptotes, okay? So you can see here for this particular problem right here that our vertical asymptote is the line x equals 0, okay? So what is that line? X equals 0. This is the y-axis, right? Let's just quickly do this real fast. So here's x, here's y, x equals 0. If I had x equals 1, that would be a vertical line going through 1, okay? So the vertical asymptote here is x equals 0, and then a horizontal asymptote is y equals 0. So now let me explain this, okay, real quick. So how do we find the vertical asymptote of a rational equation? Well, we set the denominator, whatever that is, and we find the zeros of it, okay? In other words, we take the denominator. This could be a more sophisticated expression like x plus 2 or whatever the case is, but we're going to set that and equal to 0, okay? We want to figure out when is the denominator equal to 0. When is x equal to 0? Well, that's pretty easy. When x is in fact equal to 0, okay? So whatever that is, let's say the denominator was 2x plus 3, okay, over 2, okay? To find the vertical asymptote, I would set that denominator, 2x plus 3, equal to 0 and solve that equation for x. So 2x is equal to negative 3, x is equal to negative 3 halves, and that would be my vertical asymptote, okay? So just to kind of, reinforce what I'm talking about or what the procedure is here to find the vertical asymptote, it's the 0 of the denominator. We set the denominator equal to 0 and solve. All right, boom. So now I got a vertical asymptote. That's a boundary I need to follow. All right, now how about the horizontal asymptote? Well, this one's a little bit more confusing. There's 3 cases here you can have, and it has to do with the power of our fraction. Okay, so here we have the numerator and we have the denominator, right? Of course, it's 2 over x, but we have 3 cases where where the numerator is a greater power than the denominator, something like x to the 4th over x, or we can have x cubed over x cubed where the powers are the same, or we can have a situation where the denominator has a higher power than the numerator, okay? So we have that situation right here, okay? X, all right, is a higher power than the number, okay? So in that scenario, when you have that situation with a rational equation, the horizontal asymptote happens to be y equals 0. Again, I'm kind of just quickly going over these rules. You're going to have to do more extensive study in this, but at least, you're getting a feel for, the approach that we need to take to graph this guy. Now, I did tell you that I was going to give you a secret weapon here that you can graph this and anything without even knowing it. So if you didn't know how to even determine the asymptotes or have a basic sense of what this kind of equation is, well, then there's another approach. You can, again, graph anything, but we'll get to that in a second. All right, so what do I have here? Well, I know I got a rational equation. I know I'm going to have some sort of branches. And now I have my asymptotes, x equals 0, y equals 0. And of course, this is the what? These are the x and y axis, okay? So both of these, here's x, here's y. X equals 0 is the y-axis. Y equals 0 is, in fact, the x-axis. So my graph cannot touch the x or y axis. Okay, so now we just have to figure out what the graph looks like. Okay, so now here is the graph right here, okay? So you can see I have 2 branches and they're approaching the y-axis and the x-axis, but they're not touching, all right? So these, the x and y axis are acting as asymptotes. And so how can I graph anything? Well, you can graph anything you are given, all right, by always constructing a table of values, okay? You just set up your equation here and just start plugging in some numbers, okay? So start plugging in some numbers, and you basically are going to play connect the dots. Okay? You're going to have enough uh, values for your x and y table here. Now remember, x and y, these are points, x, y points, dots, and then you're going to play, connect the dots. If I have like enough dots, I could just draw my graph through those dots. Once I have enough dots to convince me, oh, this is the pattern of what's going on. But let's take a look at what's going on here. So when x is very, very small, this graph is very, very large way up here. And when x is very, very large, this thing is getting very, very small. So let's just plug in like a very large number for x here. Let's say 100, okay? What is y when x is 100? Well, if I plug in 100 for x, I get y equals 2 over 100. Of course, that reduces down to 1 over 50. So that's pretty small, right? So 1/50th. So way out here is a point. X is 100 and y is 1 over 50, which is a very, very small value. Okay, so you can see that this graph is kind of approaching this way. Now I could do a lot of other values in here. Let's say when x is 10, what is y? Okay, so when x is 10, what is y? That's going to be 1/5. So what's bigger? Okay, 1/5 is quite, it's a much bigger number than 1/50th. So when x is 10, it's 1/5. Now when x is 1, what's going on? Well, when x is 1, when I plug in 1, y is 2. Interesting. Okay, y is 2. It's starting to go up. How about when x is, that was when x is 1. But what about when x is, let's say, 1/10? All right, let's say it's really, really small. What's going on? Well, what is the value of y when x is 1/10? All right, of course, we got to know how to deal with these complex fractions. So 2 divided by 1/10 is the same thing as 2 times 10 over 1. So that's 20. Okay, so when x is 1/10, y is 20. So this point up here would be x is 1. Let's put it right here. X is 1/10, y is 20. So hopefully you kind of get an idea here. I could just plot a bunch of points and create a table of values. You kind of need to do that until you get a better feel for how to do this. And now this particular rational equation has symmetry, okay? And when we plug in negative values for x, you'll get negative values for y, and you can see we have nice symmetry going on here. But this is how you approach graphing a rational equation, okay? You need to know vertical and horizontal asymptotes, but if you didn't know anything, you could just be like, I don't know how to graph 3x to the fourth minus x squared plus x minus 8, if y was equal to this. Okay, what does that look like? I have no idea, but we could just start plugging in values and make our table really long. Get as many values you need until you get a sense of what's going on, and then you can just draw your graph. So don't forget to use table of values. When you're first learning how to graph lines, you use tables, you use these tables, and then we get away from tables. Like, yeah, we don't really need them anymore. That's absolutely false. Okay, tables of values are extremely important, but in this case, again, we need to know the behavior. Okay, we need to understand that x and y axis are asymptotes. So in other words, we're not trying to plug in some crazy number for x like 100,000. Okay, even if we did that, we'd see it would get infinitely small down here. We get very, very close. We have to ask ourselves, is this ever going to cross over the x-axis? No, but it's not. But why not? Because the x-axis is in fact an asymptote. All right. So again, kind of a lot of different concepts that we kind of introduced here to you. If you weren't familiar with the graphs of rational equations, you need to know how to find vertical asymptotes and horizontal asymptotes. And again, Um, if you're struggling with this, you can do a couple things. If you just need a quick cheat sheet on this, you can check out my Algebra 2 and Trigonometry notes, the basic procedures in there. But if you really want to master this stuff, you want to check out like my Algebra 2 course. All right, so if you found this video educational, enlightening, or maybe just flat out liked it, please consider smashing that like button. I would actually like that. And also would love for you to have uh, become a subscriber to my channel. Okay, I am posting new stuff all the time. Of course, I'm obsessed with teaching mathematics, and my goal is always to teach math in a kind of clear and understandable way. Right? I'm trying to explain it, the topic to you, such that you understand it. Everybody wants an explanation. I'm not trying to teach to you. I'm trying to explain math to you. There's a big difference there, but I'm trying to get you to like the topic because I want to see you, rise to your full potential, which is much higher than what we're going over here. Okay, believe me when I tell you, even if you're struggling with algebra, you can ace calculus if you really put your mind to it. And I think you should because it's such an awesome topic. The more you study math, the better you're going to be just by, it's you're developing your critical thinking, with information, knowledge, or data. It just helps you so much in life. Even though you're not going to be doing algebra problems on a daily basis, in a practical sense, unless you're like an engineer, just the type of thinking you're developing, the problem solving techniques, analyzing, all that kind of stuff really comes into play. Okay, so again, if you're confused on this, you can check out my notes, my Algebra 2 trigger notes. I highlight or go over those procedures, but you really want to jump into, like, say, my Algebra 2 course if you want to master this stuff. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.